Dear students, today I am going to explain you the types of topologies in computer networks. So first of all, we must understand what is topology, then what are the types of topologies in computer networks. So it's a topology. It's a physical arrangement of our computers and how the data is transferred over the network. So simply we can call it as the topology is here physical arrangement of our computer and logical flow of our data. So how the network system is created, in what way we have to arrange our systems, and how the data flow it's happen in network systems. We have to concentrate on both that physical structure as well as logical flow of our data. So that's why topology it plays a major role in the computer networks. If the physical arrangement is poor, if the physical arrangement is not well planned, definitely it will be affect the logical flow of our information. Now it's coming to the types of topology. So we have around 6 different types of topologies which is available. Here it's a start from the bus topology, then a ring topology, third one is the star topology, fourth one is the tree topology, fifth one is the mesh topology, and the last one is the hybrid topology. Now in this video we are going to discuss about the first type of topology. What are the important things which we have to consider for bus topology? Then we will see one by one in the upcoming videos. Right? Now it's coming to the bus topology. The word itself we can understand what is bus topology. So here every computer is connected with a single cable. So here the station 1, 2, 3, 4, 5, 6, around 6 different PC I am connected with a single cable, and each the cable it's connected with the switch which is called as a drop line. So in the previous video already we clearly explained how to create this structure. If you are not known how to create this structure, please watch the previous videos, and you come to this the topology, then easily we can create the structure in what way we have to design the network. Now so this diagram totally 6 computers I placed and 6 switches I am connected with each computer. So simply if you are a new user, you are new to the Cisco Packet Tracer, please go on to that the end devices. Here you select PC and place it over here, and it's coming to that the network devices, select switches, and you can choose any one of the switch here. I used that is PT switch, or you can use the 2960 and place it here. That's the second part. And third steps we have to connect the devices. So for this diagram I used automatic connection type. You can choose either copper straight line through or copper crossover. Instead of these two cables, today I used common, that is connection type, automatic connection type, to establish the connection. So it's easily we can create the structure. Just to place 6 computer and 6 switch and select that is automatic connection type and make it the connection to all the systems. And what the IP address I set for each PC, it's a start from the 192.168.1.1. Here 1.2, it's 1.3, 1.4, 1.5, 1.6. I not changed any order, just in the sequential order to easy understanding as well as to easy to remember the IP address. I make it the series, it's a start from 1.1, 2, 3, 4, 5, 6. So as we know that how to set that IP address, so in this first video I will explain how to set the IP address. The remaining the types we can easily understand how can set that IP address for each PC. So just you click on the PC and go to desktop, select IP configuration. Here the static IP address we are going to set for this connection, that is IPv4 address. So what the IP address I mentioned here in that label, so the same IP address I typed it here. So already I did all the work. So it's 192.168.1.1 and click here in the subnet mask. The subnet mask address, it will come automatically. No need to type the subnet mask address. And close this window and you do the same thing for all the PC. Just to go to desktop, it's the select IP config. It's 192.168.1.2. Right? Right. Okay, so we created the network structure, we connected the components and we set that IP address. The process is over now. And here I said that when the PC is connected with the switch or it's maybe as a hub, we can call it as the term which is called as drop line. And coming to the end, so here there is no more connection after this station 6. At the end of each place, it's a start from that that is switch 0 and at the end of switch 5, these two switches which is called it as it's a terminator. There is no more connection after that. So that's the reason we call it as the name which is called as terminator. Now coming to the part of a technical aspect of bus topology. So here the bus topology, it transmits the data from one end to another end. So whatever data we are transferring, for example station 2 to 4 or 4 to 6, we can transmit the data only in single direction. So for example station 6 to 4, we have only one way to transmit the data. So what way you can transmit the data? So station 2, it reaches to switch 2, then definitely it comes to switch 3 and you can reach the station 4. There is no other way to transmit the data. So whatever the network is designed in the bus topology, when we try to transmit the data, we have to follow the direction of our data flow. We have no other options to reach the station 4. So definitely station 2, it comes to switch 1 and it reaches to switch 2, then it comes to switch 3 and finally it can reach station 4. Now, so next step, it's already I said that it's only one direction we can send the data and there is no bidirectional way we can transmit the data, or there is no bidirectional features which is available in the bus topology. And next thing what we have to consider here, in bus topology we have call it as the term which is called as multi-point connection. So what it means? So each switch it is called it as a pointing device. So here there are 6 stations. 6 stations we have 6 switches and each switch it is called it as a point or the station which we have to transmit the data. So it is called it as a multi-point connection, and in case if any of the point or the switch it fails, definitely it will be affect the entire network system. So which is called it as that bus topology is the non-robust topology. Now it's coming to that the advantages of bus topology. So what are the advantages? It comes under bus topology. Each topology it has some advantages and disadvantages. It's coming to the bus topology. So here the bus topology, as we know that this part, the middle line, which is called it as a single cable which is connected. So it's compared to this other topology, the cabling is less and we can create the network structure in an easy way. There is no complexity over here. So simply just you are placing the PC and it's connected with the switch. So it's easy to configure our network structure, easy to design, and it's less cabling only we are using in that bus topology. So when we are using that less number of cables, definitely it will be reflect in the cost of the cabling. So the cost of the cabling is also less it's compared to other topologies. Right? So these are the things which comes under the advantages of topology. Now it's coming to the disadvantages of bus topology. So already I said that if any of the switch it's failed to transmit the data, or any of the switch is crashed, or it has some interruption over the network. So for example, think about that the switch 2 it's not able to communicate with the neighboring switches. So definitely we cannot transmit any data to that entire network. So in case if the switch it's allows to send the data, it's allows to send the data properly, it's working properly, then only we can transmit the data over the entire network. So the disadvantages of bus topology, if any of the switch or any of the system is have any problem over here, definitely we cannot execute bus topology. So that's the reason it's a major disadvantages of bus topology. And it's coming to the next one. So in case if the data transmission rate or the network traffic is heavy, so we have to transmit the data. For example, station 1 try to send the data to all the remaining 6 stations. Got it? Now station 2 it's try to send the data to the remaining 6 stations, remaining 5 stations. So likewise, if all the stations or all the PC it's try to send the data to each other, but we are having only one the central cable we can transmit the data. Now think about that. If the station 1 try to send the data to remaining 5 PC, means already the load is heavy in that cable. Now again all the same 6 stations it's try to send the data to all the remaining PCs. Think about that, how much load it's handled by the central cable. So definitely it will be affect in the performance, right? So the network traffic is happen, or if it is the network traffic is heavy, definitely it will be increase the network collisions. Definitely it will be some data may be crashed, some data may be lost, some data may be may not reach out to the respective stations. So these are the things it comes under next disadvantage. So third one, even all the data it's transmitted over the single cable. So definitely it's the come to the part of security, it's very less secured compared to these other topologies. So what it means? So station 1, it's depend on only one cable to transmit the data. At the same time, for example, station 4, it's depend on the same cable to transmit the data. So the security level of the bus topology is very, very less it's compared to these other topologies. Right? Now, just I am summarize the things what we discussed now. So each PC is connected with one switch and the cable which is called as drop line, and the end of the point, starting point and ending point, it is called as terminator, and only one direction we can send the data. It's not support that bidirectional way. And the entire system we have multi-point connection, and it's coming to the advantages. So as a advantages, it's required only less cabling in the bus topology, and the cost of the cable is less it's compared to this other topology. Now it's coming to the problems of bus topology. If the cable have any problem or it's trouble to send the data, definitely it will be collapse the entire system. It will be crash down the entire network structure. And if the network traffic is heavy, definitely it will be creating that network collisions over the network. And the last final step, the security of the bus topology is less it's compared to the other topologies. So these are the things is very, very important when we are studying or when we are working the bus topology. Right? Now I will show you how the data is transferred in the network topology. Just I am going to place one message from station 1 to station 4. The connection is successful. Right? So immediately we got the message is successful, and the same thing I will show you in the simulation window. So station 1 send the data to switch 0, and it comes to switch 1, then it reaches to switch 2, okay, it comes to switch 3, finally it reaches to station 4. So think about that. In case if I place a message to all the stations, so really it will be create some network traffic over the cable, right? So only one message I place it here. So if I set that messages from station 1 to remaining all the 6 stations, definitely we may get confused how the data is transferred, which acknowledgement it comes to that end, which message, which station it's received that message properly. Really it's have some confusion, we may get it over the network structure, right? The same thing I will show you in the ping command, how much the time it's taken to receive the data. So for example, I am going to ping that command from station 1 to, I try to ping with station 3. So go to desktop and select command prompt. Now just you type it here, it's a ping 192.168.1.3. So I clicked station 1, that is the first PC. First PC it's going to ping with station 3. So that's the station 3 IP address is 192.168.1.3, right? Just to click the enter. So still it's taking some time to get the reply, even we are connected with only one PC. Just I close it and I delete the previous statement, and I try to do one more time. Yes, so the previous message what we, once I close the window, and the meantime it's received the response. Okay, right, look at the message what we received through the ping command. It's we ping with the station 3, and here that number of packets sent is 4, received 4. There is no packet loss here, and approximate round trip time in milliseconds, its minimum is 8 milliseconds, maximum is 16 milliseconds, and average time is 10 milliseconds. So here the same way you can check remaining all the PC, how much time it's taken to communicate with other PC, and what's the minimum time, what's the maximum time, and we can understand that. So what's the problem in the bus topology, and what's the time taken to transmit the data to the remaining PCs. So just you can work it out. You connect the ping command with all the remaining 6 stations and check the time, what's the difference between each stations. Definitely we can find that exact working model of bus topology. So just I connected with only one ping command. If you try to ping all the remaining 6 stations and check it, is the same type of message you're getting, or in any other difference with the timing in the entire network structure. Maybe for example station 1 2 3 it takes that is 8 milliseconds, and maximum time it's 16 milliseconds. If you try to do the same thing with station 1 to station 6, definitely it may be differ, and the time may be it's less, or it can be as high. So the same way you got to check the remaining all the PCs which is connected with the network, and you have to do the analysis. So what's the minimum time it's taken, what's the maximum time is taken, and what's the average time in the bus topology, right? And I hope this concept is clear to everyone. And the next video I will try to explain how the ring topology is working, and what are the major things which is comes under ring topology, right? Thank you. Thanks for watching.